Hello, I'm Angie, Field Application Engineer from Moxa Australian team. In this video, I'm going to introduce two seamless redundancy technologies called PRP and HSR. They are recommended by IEC 61850 for substation automation networks. Communication network redundancy is the key to building reliable automation systems. And recovery time is how we normally measure effectiveness of a redundancy protocol. IEC 61850-5 suggests different recovery time for different applications. For example, IED interlocking using Goose protocol requires less than 4 millisecond recovery, while sample values and the busbar protections requires bumpless recovery. In other words, 0 millisecond failover. PRP and HSR are defined in IEC 62439-3 and designed to fulfill this requirement. The two protocols are different topologies but share the same idea, which is packet duplication. Let's take a look on how it works in more details. PRP stands for Parallel Redundancy Protocol. As the name suggests, reliability of communication is based on the use of two parallel networks, called LAN A and LAN B. Each PRP device has port A and B, which are connected to corresponding LANs. If a device does not support PRP natively, it should be connected to PRP network using Regbox. Every packet sent by PRP nodes is duplicated. One copy goes through LAN A, while the other goes through LAN B. During normal operation, the receiving side would get both copies but use only the one that came first and discard the one that came later. Creating and discarding duplicates is done using special hardware either in Regbox or embedded into a device. At any time, we can afford to lose one of the LANs without any packet loss, so the network recovery is seamless. Another option to achieving 0 millisecond recovery time is High Availability Seamless Redundancy, or HSR for short. It could be more cost-effective from wiring and device quantity perspective in small-scale networks, as it allowed us to use ring topology. The HSR module also sends duplicated packets from port A and B. Each node not only acts as a sender or receiver, but also propagates packets between A and B to form a ring topology. Once unicast packet reaches its destination, that node stops further propagation. Similar to PRP, only one copy is used and the second one is discarded. Using HSR ring topology eliminates the need for network switches. However, all devices in the ring must support HSR due to the special frame format that will be considered abnormal by the regular Ethernet device. There are more options when it comes to building larger scale networks with seamless redundancy. If you want to build a topology with multiple HSR rings, quad-box functionality can be used to bridge rings together. And if you need to connect HSR to PRP, you can rely on the coupling mode of the Regbox or PRP HSR switch. Both PRP and HSR can provide bumpless recovery suggested by IEC 61850 for process and station buses, while PRP sends duplicated packet over two separate networks and allow using each LAN for regular communication as well. HSR is based on the ring where network switches are not required, but all devices have to be HSR compliant. Both protocols require specialized hardware to send and receive the packet, either built into IED or external like Regbox. The protocols can also be combined using coupling or quad-box to build large-scale topologies. Thanks for watching. See you next time.